Hey class, today we're going to be doing section 4.15, part 1 of our AP Stats course, which is talking about random variables. So a random variable is a numeric value based on the outcome of a random event. So let's look at this following scenario. Shane took his minivan in for repair because the air conditioner was cutting out intermittently. The mechanic identified the problem as dirt in a control unit. He said that in about 75% of such cases, drawing down and then recharging the coolant a couple of times fixes the issue and costs only $60. If that fails, then the control unit must be replaced at an additional cost of $100 for the parts and $40 for the labor. Find the average cost of such a repair. So if you're looking at average and you think about averages, you add the two values together, divide by 2, like we used to do averages for just basic numbers. Unfortunately, that's not going to work here. And the reason why, if we take the cost of $60 plus the cost of 60, 100 plus $40, if you have to go the other route, and divide by 2, we get $130. But the flaw in this is that you're assuming that both of those repair scenarios are equally likely. If the two scenarios are not equally likely, we can't just calculate a regular average. We have to take into consideration the two probabilities. So being able to do this problem, we can use the expected value equation that we get from AP Stats, and we can find this on our AP Stats formula sheet. And the expected value, or mu, this little symbol here, mu, is a Greek letter mu sub x, or e of x, you'll see it both ways, is the sum of each x value times the probability of that x value. So if we look at the example from above, we have the mean of x, or the expected value of the repair cost. I'm going to put some context in here. As you know, it's very important in AP Stats. We're going to get, so it could cost $60, and that happens 75% of the time, plus it could cost $200, so the initial 60 plus 100 plus 40, and that happens 25% of the time. And we would get an expected cost of $95. Now, I know that might sound a little weird because you wouldn't expect to pay $95. You're either going to pay $60 or $200. But this is how the math works. So, in the long run, that would be your expected cost each time you have one of these repairs. Example 2, a game involves rolling a standard six-sided die. You win $100 if you roll a 6. If not, you get to roll again. If you obtain a 6 on the second roll, you win $50. If not, you win nothing. So what is the expected amount we will win? So expected, or mu of x, or expected value of x, is going to be $100, but that only happens if we roll a 6 the very first time, which is only a 1/6 probability. Plus, we might get $50, and that happens if I roll not a 6 the first time, so 5/6, times if I roll a 6 the second time, which is 1/6. Remember, if I want 2 rolls, the probability, these are independent events, so I can just do the probability of the first roll times the probability of the second roll. Plus, I could get $0, and the probability of that would be not rolling a 6 and not rolling a 6. Now, I know that the $0 won't really factor in. If we multiply something by 0, it's just 0. But we want to show that we've thought about all 3 options. If you don't show all 3 options so that you have the 100% of all your options listed, you will lose points on the AP Stats exam. So just make sure you get it in there, even though it's not going to affect our probability or our expected value. All right, and the expected value ends up being $23.61. So if the person running this game is smart, he will charge more than that, maybe $25 to play or something like that. All right, what is the minimum amount the person running the game must charge to obtain a mean profit of $3 per play? So if he's expected, so the person running the game is expected to lose $23.61 every time someone pays or plays, then if he wants to gain $3, he needs to add $3 to that So he needs to charge a minimum of $26.61. All right, so let's shift gears to, oops, not quite shift gears, sorry. My page had scrolled down there. All right, so next example. Airlines routinely overbook flights because they expect a certain number of no-shows. An airline runs a 5 p.m. commuter flight from Washington, D.C. to New York City on a plane that holds 38 passengers. Past experience has shown that if 41 tickets are sold, then the probability distribution, remember probability distribution is a probability table, for the number of people who actually show up for the flight is summarized in this table below. So we can see those pieces. Assume 41 tickets are sold for each flight. There are 38 passenger seats on the flight, so they're selling more tickets than they have seats for because they're expecting people not to show up. What is the probability that all the passengers who show up for this flight will get a seat? So the probability that all passengers get a seat would be equal to the probability that either, and if you notice, 36 is the lowest number of people they expect to show up. So either 36 show up or 37 show up, or 38 show up. So if we find these probabilities and take, so it's an or probability, so we're going to add these together. Then we can figure out the probability that all the passengers who show up are going to get a seat. So the probability that 36 show up are 46%. We've got 30% probability that 37 will show up, a 16% probability that 38 will show up. So we have a 92% probability that everyone who shows up is going to get a seat. It's a pretty strong probability there. What is the expected number of no-shows? So now if I want the expected number of no-shows, I need to make sure that my numbers represent the number of no-shows. So if 36 people show up and 41 tickets were sold, then how many people didn't show up? Well, that was 5 people. 4 here, 3, 2, 1, and 0 if all 41 show up. So when I do my expected number of no-shows, I would have 5 times the probability of that happening, plus 4 times the probability of that happening, plus, and we can do a ... little shortcut in stats here, plus 0 times the probability of that happening. Make sure you show at least 1 or 2 at the beginning, a plus, a ... another plus, and at least 1 or 2 at the end. And if I plug that in my calculator, all the pieces, including the parts I didn't show on my paper here, I get an expected value of 4.1. Given that, so you would expect 4.1 people not to show up. Given that not all passenger seats are filled on a flight. Oh, okay, so we have a probability, conditional probability problem. So given that not all seats are filled. So that's our given probability. What's the probability that only 36 passengers show up? All right, so remember our conditional probability formula means I want the probability that only 36 people show up and not all seats are filled. So, well, if only 36 people show up, not all seats are filled. So those are definitely together there. So that's 46% probability on the top divided by the probability that not all seats are filled. Well, not all seats are filled is going to be if 36 people show up or if 37 people show up. And those are those probabilities. So I have a 0.46 on the top, a 0.76 on the bottom, and that's going to give me a probability of 605, so 60.5%. All right, so now let's switch gears a little bit and talk about standard deviation of our random variable x. So standard deviation, this is also on our AP Stats formula sheet, so you don't have to memorize this formula, just make sure you know how to use it. We have standard deviation of x is going to be the square root of the sum of each x value minus the expected value of x. So we do need to find the expected value first, squared times the probability of each x value. And then just a quick note, sigma sub x, so standard deviation of x squared, is the variance of x, and that's just the part on the inside. So square root of x minus mu sub x squared times probability of x. So if they ask you for the variance, that's just the square of the standard deviation, or just the inside of the square root part. So let's see, that's the variance. Okay. Let x equal the number of defective tires on randomly selected automobiles. So we have defective tires, the probability of that number of defective tires. Find the value of y. So if you notice, I don't have the value of y. Now in a probability distribution or a probability table, all these probabilities have to add up to 100%. So I can find y by taking 1 and subtracting the ones I have, so that they can all add to 100%. So 1 minus 0.94 is going to give me 0.06. So y is going to equal 0.06. Calculate the mu, or the mean of x, or the expected value of x. So 0 times 0.54 plus 1 times 0.16 plus 2 times 0.06 plus 3 times 0.04 plus 4 times 0.2. And that's going to equal 1.2. And sigma sub x, and I know that I'm going a little fast. I don't want the video to take too long. So you can use a calculator, plug all those things in, make sure you're going to get the same answer. And actually, I'm going to show you a shortcut on the calculator in just a second. All right, now the standard deviation of x. Here we have the square root of, so now it's each x value, so for example 0, minus the expected value squared times the probability of that x value, which was 54%, plus the next x value, 1, minus the expected value, 1.2 squared, times the probability of that one, which was 0.16, plus, and I'm going to put dot, 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 and just do the last one. So 4 minus 1.2 squared times the probability of that one, which was 0.2. All right. And then if we plug the inner calculator, and I know it takes a while, but carefully plug all those in, we get 1.587. Now, I'm going to show you a shortcut, because your calculator will actually do all this for you. But I want you to know that on AP Stats exams and my exams, if you don't write out what you see on my paper here, if you don't write out the formula with your work and you just use a calculator, you will not get credit at all for your answers. So make sure that you write this out, but then instead of having to spend time plugging it into your calculator, we have a shortcut. So go to Stat, go into Edit, and then I've already pre-done my numbers here. So for example, I have L3 is my x values, 0, 1, 2, 3, and 4. And my L4 are my probability values that we have there in our table. Now, to figure out our expected value and standard deviation, we can do both. And this is especially helpful if it's a multiple choice question. That means it doesn't matter if you show your work or not. So this is really, really easy way to get your answer for multiple choice especially. So go to Stat, go to Calc, go to one var stat. So remember, we only have one variable. I know there's 2 rows in our table, but one of them is the variable x. The other one is the probability of that thing happening. So it's not 2 variables. It's just one variable. And we have our list. So our x list is in L3, or if you put yours in L1, wherever your x values are. Frequency list. Let's talk about frequency. Frequency is how often something occurs. That's the same as probability. Probability is 0.54. That means it occurs 54% of the time. So your probability list is going to be your frequency list. Calculate it, and you can see our expected value, our mean of x bar at the top is 1.2, and our standard deviation, sigma of x, is 1.587. So this saves you some time. You don't have to plug in that long string of numbers in your calculator, but you do need to write them on your paper. You can do the plus dot, 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 plus in the middle, but you have to have some work on your paper. All right, next example. This is our last page here. As the head of inventory for a computer company, you were thrilled that you had managed to ship 2 computers to your biggest client the day the order arrived. You were horrified, though, to find out that someone had restocked refurbished computers in with the new computers in your warehouse. The shipped computers were selected randomly from the 15 computers in stock, but 4 of those were actually refurbished. Okay, so 4 of those were refurbished, and there were 15 computers in stock. If your client gets 2 new computers, things are fine. If the client gets 1 refurbished computer, they will send it back at your expense. So if we have 1 refurbished, it's going to cost you $100. If both are refurbished, the client will cancel the order, ship both back at a total loss of $1,000. Oof. Okay, create a probability model and find the expected value and standard deviation of your company's loss. So first, we need our X values and our probability of those X things happening. So if I'm finding the expected value of the loss, and I'm going to, of your company's loss, that is what X is going to represent. So when you're figuring out what X represents and the probabilities, you're going to be using the company's loss. So the company could lose $0 if you shipped them 2 new computers. Or the company could lose $100. And there's actually 2 ways that that could happen. So I'm going to write 100 twice, and we'll talk about that. Or the company could lose $1,000. So the company will lose $0 if both computers are new. So if I have 15 total computers, 11 new and 4 refurbished, okay? So what's the probability that I ship 2 computers that are both new? Well, the first one would be 11 over 15. So there's 11 new out of a total of 15. And then the second one would be 10 out of 14 because we have 1 less computer total and we have 1 less new computer. All right, and then for the 100, so the reason why I have 2 of these is there's 2 different options. Let's say the 2 computers, right? It's easier to picture them as different types of computers. So imagine one is a desktop and one is a laptop. So if the desktop was new and the laptop was refurbished, that's a different scenario than if you switch that and the desktop was refurbished and the laptop was new. So we have to count both of those probabilities. So if one was new, so 11 out of 15, let's say the first one was new and the second one was refurbished, 4 out of 14, that's going to give me my probability of one of them, the first one being new and the second being refurbished. If the first one was refurbished, so 4 out of 15, and the second one was new, 11 out of 14, we get that second one. Now, if we think about how we multiply fractions, those are the same. So you could have just taken that probability and multiplied it by 2 because it's the same. But I'm going to write it out just so we can see that difference. And then $1,000 loss for your company if both were refurbished. So 4 out of 15 times 3 out of 14. All right, now you can find the decimal values for each of these. I'm just going to leave them the way they are. And let's look at our expected values. So expected loss is going to be 0 times 11 over 15 times 10 over 14. So the X value times the probability plus, and then I'm going to just do dot, 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 plus, and then the last one, 1,000 times 4 over 15 times 3 over 14. Again, we can use our calculator to give us a little bit of a break here. So let's go in and let's just clear our list. So if you have to clear your list, go up, clear, enter. Go up, clear, enter. All right. So my list 1 is going to be my expected losses. So 0, 100, 100, and 1,000. Oops, that says 10. 100, 100, and 1,000. Sorry. Okay, there we go. And then here I'm going to have, okay, so let me see. I can actually put numbers in here. So 11 times 10, and then, oops, delete. And then I have divided by 15 times times 14. So that'll give me that number. And I can do this for each one of these. So I'm going to try to do this a little faster. Okay, so we have all of our values in there. Now I can go stat, calc, one var stats. I'm going to change this to L1. Go down, change this frequency list, my probability list, to L2. Calculate. And then this just saves me time. And I know it took me a few minutes to plug in my list here, but now I don't have to plug it in for the expected value and the standard deviation. So my expected value, so the company's expected loss is going to be $99.05. Remember, context in problem. And then our standard deviation of our losses. So again, you have to write out the formula, at least the first and the last. So 0 minus, let's see, point, or no, sorry, not point. We've got our expected value, 99.05 squared times 11 over 15 times 10 over 14 plus ... And then the last one, we have 1,000 minus 99.05 squared times 4 over 15 times 3 over 14. And then I don't have to plug that in because I can see it in my calculator here. I have a standard deviation of $226.99. All right, last example. You play 2 games against the same opponent. The probability you win the first game is 4.4 or 40%. If you win the first game, the probability you win the second game is 0.2. If you lose the first game, the probability you win the second game is 0.3. Are they independent? Absolutely not. They are not independent because winning or losing the second game, or I should say the first game, changes the probability you will win the second game. So the outcome of the first one changes the probability of the second one. That means they're not independent. What's the probability you lose both games? So the probability we lose and then we lose again. So if the probability we won the first game is 0.4, then 0.6% that we're going to lose. And then it says, if you lose the first game, the probability you win the second game is 0.3, which means the probability I lose the second game would be 0.7. I get 0.42 for that probability. What's the probability you win both games? So probability of a win and a win. The probability I win the first game is 0.4. The probability if I win the first game, the probability I win the second game is 0.2. And that's going to be 0.08. Not a great probability you're going to win both games. Let X be the random variable of the number of games you win. Find the probability model for X. So X, probability model, this is going to be our table. So X and probability of X. So number of games I win, I could win 0 games. I could win 1 game, or I could win 2 games. Now, I found that the probability I lose both games is 0.42. So I already have that piece. The probability I win both games is 0.08. And they all have to add to 100%. So 1 minus 0.42 minus 0.08 is 0.5. So there's a 50% chance that I'm going to win one of the 2 games. What are the expected value and standard deviation? So expected value is 0 times 0.42. There's only 3 of these. It'd be silly to do a plus a ... in the middle. 2 times 0.08. And we get 0.66. You can use your calculator to double check if you'd like. And then standard deviation, I'm trying to rush the end of my video here. 0 minus the expected value squared times our probability plus, and then this is longer, so I'm going to do a ... in the middle. 2 minus 0.66 squared times 0.08, and that should give you 0.62. And there are the number of games. So you're expected to win 0.66 games, which I know is silly. It's just a theoretical mathematical amount. You can think about that like, okay, if you Well, if you played multiple days, I guess, and you can add those probabilities together, eventually you figure out like over a month, maybe how many expected value or expected games you're going to win. All right, and then our standard deviation of the number of games we win is 0.62. All right, and that's it for today's lesson.